My name is Veronica Purcell, and my inquiry focuses on the impact that insecticides have on soil fertility. I chose this issue because I know the importance of maintaining soil fertility for our future generations, and therefore I wanted to learn how insecticidal presence in soil affected its fertility. Without fertile soils, future food security is jeopardized. With the proliferation in world population, modern agriculture was established to increase food production. For example, global cereal production has doubled in the past 40 years as a result of practices such as the use of fertilizers and pesticides. Tillman, Kasman, Matson, Naylor, and Pulaski. The insecticides used for pest control are ending up in the soil, which can disrupt and decrease the population of microorganisms that contribute to soil fertility. These microbes include bacteria, fungi, algae, and protozoa, which all play important roles including nitrogen transformation, organic matter decomposition, and nutrient release, as well as stabilization of the soil structure. Rathor and Nolet. Research into this issue was quite in-depth. Google Scholar was utilized with the Curtin Library activated. The Curtin Library provided many relevant databases containing peer-reviewed articles. ProQuest, Science Direct, and Access Digital Library were databases located through Curtin Library. Keywords searched included insecticides and soil fertility, microorganisms and soil fertility, and natural pest control in agriculture. At times, research was difficult due to many articles focusing on pesticides as a whole group rather than just insecticides. However, the few articles located were valuable. The most useful tool was having access to many databases through Curtin Library. In 2002, approximately 8,000 tonnes of insecticides were being used in Australian agriculture annually. While the purpose of insecticidal use is to combat insects, a substantial amount reaches the soil. The common makeup of soil is a complex mixture of minerals, water, air, and an abundance of microorganisms. The depletion of soil microbes would devastatingly impact soil fertility by eliminating the processes required to grow and support plant life. Lowe found that certain insecticides stimulate the growth of microbes, whereas others have a depressive effect. For example, 2 common insecticides applied to agricultural loam significantly decreased some denitrogen-fixing bacteria, whereas 2 other insecticides stimulated that same bacteria. Furthermore, Lowe reported a decrease of nitrification in soil after application of the insecticide phenamifos. Carlier and Gossel reported a significant increase in overall bacterial biomass, but a decrease in fungi biomass following insecticidal application on a loamy soil. As can be seen from the various studies, discussion about insecticides and soil microbes has to be very specific. This is due to the varying types of insecticides and the abundant species of soil microbes. Different insecticides affect different microbes in various ways. To eliminate the risk of negative impact on soil microbes, alternative pest controls can be implemented. Biological pest control is achieved by introducing living organisms that kill or weaken pests. Neeson outlines other approaches, including cover crops and rotating crops, keeping the site clean, and traps and pheromone products. Existing studies report that while some adverse effects occurred to soil microbial activity as a result of insecticidal presence, this generally recovered and returned to normal. Therefore, at this stage, it seems the impact insecticides have on soil fertility is not as negative as initially thought. However, Rathor and Nolet state that while the use of insecticides may have no immediate impact on soil fertility, in the years to come, beneficial microbes may be unable to recover after persistent long-term presence of insecticide. To fully gauge the possible long-term harm insecticides might have on microbial processes, extensive long-term studies should be implemented. Akara states that in Year 6, students learn that the growth and survival of living things are affected by physical conditions of the environment. Students could gain this understanding by learning that microbe population can survive and increase or be suppressed after insecticidal application.